Hey, what's up? Um, I'm gonna give this a couple minutes and then edit the beginning later on because I screwed up the stream setup. I scheduled it on LinkedIn at 10 p.m. And I didn't notice it till like now. So I had to go ahead and change things. So I'm just gonna leave this here for a moment, and if uh, people join, cool. If not, well, maybe next time I'll learn to read the time correctly. Um, I'm just getting the rest of my things set up over here. I have a cluster, and let's see, what am I using for instances? These are no, these are not R3 XLs, are they? These are. Let's see now. Stress is a C7I2XL, which is probably too much. That's okay. R5D2XL. That's what we're rolling with today. And the reason why I'm using those is because they have a bit more memory and they have local NVMe drives. So yeah, I'm just going to go ahead and get started now. I'm just going to share some stuff from last week because I think that was last week was kind of interesting, the way that the my attempt at running a whole bunch of different things at once didn't really work that great. And what ended up happening was I started seeing some performance problems, and I noticed that there was a couple errors going on in the GC logs, and everything was a bit backed up. So there's a couple ways you can kind of think about concurrency, right? And its effect on garbage collection. So if you have a fixed number of requests that you can do at any given time, and it looks like you have available CPU, like you have available resources in the machine, it's possible that you're artificially starving your process. I was just using the default of 128 native threads. Now, when I looked in TP stats, I could see that was backed up. So I took I just kind of threw out a guess. I increased the number, I doubled it. And the question was, is that going to fix things? It didn't. And then I ran out of time. So basically, we're at this point where I didn't really get to any satisfying conclusion. But I did get an email afterwards from Bowen Song, and he pointed out that if it's a GC issue, then might be better off by lowering the number of threads. The idea being less concurrency, less context switching, less stuff going on. And if you have fewer things going on at once and you have better concurrency, or if you have less concurrency, then you can actually get things done faster and push things through the queue. So I tried that for the sake of trying it. Unfortunately, it didn't really have any effect. What was actually happening is that ZGC was just not keeping up. And I want to show a quick thing here. I'm not affiliated with these guys, but I am going to plug them because this is like one of the best tools I've ever used. So if we look here at my this graph, this is a graph of heap usage. And what's interesting about this is that this point right here where things kind of go sour, let me just draw on it, I guess. Let's see, can I use a bigger marker? Yeah. like right here. Yeah. So that's where things kind of just start to get wild. And essentially what happens, so refresher. So ZGC, the idea is that it can do a lot of its work concurrently with the running application. And instead of stopping everything, it's going ahead and it's cleaning up garbage as the application runs. And it's doing very, very short pauses. Um, like insignificant ones, like less than a millisecond a lot of the time, and which is super cool in theory. Unfortunately, Cassandra has an allocation problem still. Cassandra massively over allocates. So what actually happens is we have this increase in GC, or increase in objects that are being allocated, but they're not being collected. And then once we get to this point right here, everything kind of just becomes terrible. It can't it can't keep up. There might be a little bit of work that gets done, but effectively, what happened is the whole cluster got locked up. The whole cluster was unresponsive, and that is pretty bad. So I definitely, I think ZGC is interesting. I looked a little bit more afterwards, and the folks that wrote it actually did a test with Apache Cassandra. And one of the things that's coming, or that's available in Java 21, which I haven't tested with yet, is a generational ZGC. So ZGC is just broken up into kind of a flat space. Cassandra really benefits from generational collection because there are some objects that live a little bit longer, and there's some objects that don't live as long. So generational actually makes it easier to do some of the collection. So with all that said, we're just going to take a break from the ZGC side of things, and what we're going to do is put some load on this cluster, and I'm just going to jump on here. You can see nothing's going on yet. I actually haven't had a chance to start this up. I found a bug in my tooling, and unfortunately, I literally just got these boxes up a moment ago. So what we're using right now is a build of Cassandra 5. So this is actually a build from this morning. I think that the commit is like, I don't know, if there was stuff committed today, then we would have today's commits in it, which is I think pretty cool. Like, this is one of the reasons why I built this tool initially, was to be able to do tests like this, because I love the idea of saying like, hey, I actually want to do some performance analysis. I'm just going to get rid of this. I want to do some performance analysis on my cluster, but it can be really kind of a pain to set this stuff up if you don't already have the tooling to spin up an environment. Then it can be a pain to do it. It can also be kind of a pain to do it if you do have the tooling, because like not all environments allow, like most people don't have the ability to deploy custom builds of Cassandra. It's kind of like it's a weird niche thing to just like roll out like arbitrary builds, and we had it at Netflix. I'm pretty sure it's at Apple, but you also have to take into account that like you might not fully control that environment. Like, I didn't build any of the infrastructure at Netflix or Apple that was responsible for running this stuff. So not all my tools were on there. Like, I like the tools at Netflix were pretty good, but the tools at Apple were a little lacking, and I don't remember if I had full root access, but it's one of those things where I'm kind of controlling with this sort of thing, and I like to be able to just do whatever I want to do without having anybody tell me what to do. So I'm actually going to grab. I should have done this before, but I'm going to grab a build of Cassandra Stress that I had. I gotta upload it from here. Okay. So we are just going to go ahead and copy this build. So I should probably do it. So basically, what I've done here, like I put up a build of easy cast stress, like back when I just kind of changed all the packages around. But since then, I've added some really cool functionality, and some of it is going to be really interesting. Like I built it, and I was like, oh, this is going to be really simple. And then as I started using it, I was like, oh, this is actually really cool. So now what we have in the main branch, and that's what this build is. My dogs. Hey guys. What we have is now the ability to, instead of just like turning it on and trying to have it run full blast, I've discovered that the Guava rate limiter that I'm using isn't the best for this sort of thing. And in general, it definitely helps to have a warm-up phase associated with this. So basically what it does is it breaks up the whatever you told it you want your target rate to be. Like if you said 5,000 requests a second, it will step 10 times towards that goal. So right now it's basically like a linear thing, 500, 1,000, 1,500, 2,000. And this is pretty cool. But what I actually want it to do is to be able to do like a curve. Like I want it to be able to do 1, 10, 30, 100, something like that, and ramp up and have more of an exponential ramp. Or I want to be able to say like, oh, and by the way, it's like it's stepping every like 5 seconds. So the other thing that I'd like to be able to do is have it. I'm just going to start. I'm going to run this thing while I'm talking. The other thing I'd like to have it do is to be able to have a configurable step mode and the amount of time that it takes. So I would love to be able to run a thing, and I could say like, step it by 1,000 queries a second, but only step every, or maybe 500 queries a second or 100 queries a second, and step every minute. Okay, so it goes 100, 200, 300, and essentially like allows you to kind of like watch what happens as load increases on the cluster. So instead of just making a warm-up thing, allow the stepping rate to help you like essentially take a lot of samples to what happens. Oh, hey buddy. Hey, me too. Oh, sorry, no problem, man. I actually got delayed too. I started 10 minutes late, and my time on the stream was wrong in YouTube and in LinkedIn. So yeah, that's great. I'm a little late getting going. Where was I? Oh yeah. So what I want to do is to be able to kind of graph the throughput versus the latency on the same graph, so you can kind of see like how your latency goes up as your throughput goes up, and you can kind of like figure out what's going to happen at each stage of the game. Because a lot of the time what people do is they run like 10 tests, and they'll go, okay, now we're going to run this one at for 1,000 requests, and then 2,000, whatever. They manually step. But I think that it would actually be beneficial to be able to just say, I'm going to run this test for a day and just go ahead and like evenly step through from 0 to whatever over the course of the day, or do a linear thing, or maybe something that's more logarithmic, because when it gets to a higher level, you start to become more sensitive. So there's a lot of, and if you hear all that noise, commotion in the background, that's my dog whining. There's a lot of options, and to be honest, I hadn't really thought too much about it. I just sort of like ran this thing, and found out that like, I accidentally like was doing something that I really liked. So I'm just going to move the old version. I'm going to move it out, and we'll just leave it here in old, and then we'll move this one in. So now when I run this, so cool. So it's gonna, so let's just see if we can run anything. Make sure I'm not doing something down here. All right. So let's just see what happens if we run this. Does this work? Cool. Okay, this is the other reason why I wanted the new one. I forgot that I added this. So you can now do run. So you can do easy cast stress, run key value, dash compaction. This has been in there for the whole time. But you can now specify shorthand for UCS, and then here's your UCS parameters. So you can do like UCS comma T4. Okay, so T4 is size tiered compaction essentially, with a few nice optimizations. Like the really big important optimization is that it won't grow to like an infinite size. Like you won't end up with hundreds of gigs in, oops. You won't end up with these humongous SS tables, which is one of the biggest problems with size tier compaction strategy, especially when we're combining the like, well, especially when we want to take advantage of zero copy streaming. So the other thing I'm going to try and get in today, and by the way, I only have 1 hour, so I'm going to really try and work this pretty quickly. So here we're running, and this is going ahead. So what is this even doing? So you see here, I'm using T4 as my scaling parameters. This is just a key value workload, and I think I'm probably not going to leave it on this. This is only going to do like what, 1 million requests. So this is going to finish up soon. And you can see here, this is one of the reasons why I like the stepping thing, because in the beginning, when it's not warmed up, there is some overhead to it, as like I'm not sure if it's the internal driver stuff or if it's external to Cassandra. I haven't gone through that yet, but regardless, like, I mean, if it's the driver, then it's actually probably an easier fix than Cassandra, but and I suspect that it is, but you know, I've got a lot going on here. I've got multiple open source projects. I've got my training program. I've got the testing for Cassandra. I'm trying to get some patches in to improve Cassandra's performance on EBS, which I would love if someone is interested in that. I'm just gonna do a quick pitch for a minute here. Oops. Streaming. If someone is interested in this and wants to sponsor this work, I would be really pumped. Let's see. So for Cassandra 5, and this is probably not going to happen unless someone gets involved here. I am working on this. I'm working on the analysis side of this, but it is slow going because I got a lot going on. So someone's going to need to sponsor this work. But essentially, what I've discovered here, and this is partially from the results of what happened in a stream a few weeks ago. You know, figuring out how to get optimal performance out of EBS. It turns out that we can make a few simple changes in Cassandra. These that I've mentioned right here on this ticket. This is Cassandra 15452. If we were to get these changes in, Cassandra 5 could potentially compact and stream, repair everything quite a bit faster than it does now. This is one of the major things that blocks performance from improving. So there's two things. There's GC related things, and this, like our IO could be a lot better. And so if you take a look at what I've written in Cassandra 15.452. That analysis, I need more work on that analysis. I need to get a little bit more information out there. But we're going to be using all this tooling to verify how this stuff works. So this is like a pretty cool thing. So let's see. We are going to do random partition access today. And the reason why we're going to do that is because this is not a very good, it's deliberately built. So we're going to say, let's do like we'll do a million partitions. So hold on, let's just keep this for a sec. Easy, whoops. Okay, so this is kind of cool. I haven't really talked about this feature a lot, but easy cast stress info random partition access can actually tell you quite a bit about what the workload does. So it tells you the schema and then the dynamic workload parameters. Now, what's really cool about this, I'm just going to show this real quick. There we go. What this actually does, you can see it here. This actually grabs everything that's here in this workload parameter, and that's this. So you can basically put variable, like you can program whatever you want into your workloads. And if you mark something as a workload parameter and you just mark it as a variable, like var, because it's Kotlin, and then just add a workload parameter and you tell it like some information about it, you can just write anything that you want. Like you can write code and get super complex workloads. That's why I like this stuff. That's why I actually prefer this over any of the alternative tools, because all the alternative tools you have to use configuration. So anyway, let's just go ahead and start running this. So we're going to run random partition access. We're going to do it with 1 million partitions. And then we're going to modify the workload because rows, you know what? We're actually going to leave that 100 rows. Let's do, but we're not going to, this would be 100. Yeah. And let's just do, let's just let this thing populate with 10 million. So we'll do 10 million writes in the beginning to populate it. And then we're also going to do this max WLAT. Max WLAT allows us to set a max write latency. And then we're also going to say, like, we're going to step this thing up to 20,000. And then for compaction, I mentioned we're going to use UCS and T4. And then for reads, this is only going to be like 10% reads. So that's what this does. So I'm just going to drop this. Can I drop this in my chat here? How do I? Boom. Cool. There we are. All right. Nice. This is what we're running here. It's just going to scroll across the bottom. So if you're curious and you want to redo it, I'll just also drop it in here because I'm not a crazy person. Yeah, let's let this run for a little while. Dynamic. Yeah. Oh, I didn't specify the rows. Yeah, I'm just going to allow that. I'm just going to allow that to go. Cool. Oh man, I love my banners. This is great. Let's see. All right, so this is now going now. So this is going to run for a little bit. I don't know. There's no way that it's going to take that long. It's ramping up, so it's going to get a little bit faster over time, and we're just going to watch this. So I made a few changes to my tooling as a result of kind of some of the stuff that I noticed last week. One thing that drove me kind of crazy was that I didn't know what box I was on, and I was looking at the H top for the wrong box. So now we actually have the host automatically set up in the host name. So this, when the node starts, it goes ahead and sets this up for us. So I like that a lot. I also did this. This is pretty cool. This is HTOP. Now, HTOP is a really awesome program, but the thing that's really amazing about it is that it's super customizable. So if you do this, you can actually like show all sorts of interesting stuff in here. See, we have memory usage, load average, memory, date and time. We have all sorts of interesting stuff in here. And so I really, really like this. So what I did was I made this my default. So now I've got disk IO over here. I've got my network IO over here, memory usage. So top is actually like HTOP with all these configurations is super useful now. And you could do it all before, but you know, you don't have to like set it up every time. So if you're interested in that, you can go here into Packer. So go into Easy Cast Lab and go into Packer and check out HTOP RC. You can just drop this in to, if you look at the Packer code, which is maybe here. Oh, no, it's the other one. By the way, this is all open source. Like I'm not hoarding this. This is totally free. So you basically put it here, home ubuntu.config htop, and then you can have this really fancy htop. You're into that. Okay. So and this is also cool. So I have it set up here where you can look at the running processes, but it actually uses the names of the threads in here. So if you're kind of wondering like what's going on, you know, you can see that like GC thread workers or like how much CPU they're individually using. This is actually something that I didn't look at last week, and I mentioned earlier that Bowen Song had emailed me, and this was something that he had suggested looking at the CPU usage of the individual threads, and it was a really, really good suggestion. And so I made HTOP do that by default. So now you can actually see like what's going on here at the thread level by default. So it's one of those things where it's like it's easy to miss if you don't do this regularly, then you know you might not notice. So, oops. So what am I doing here? Okay, so now look, I'm not lost. I'm on Cassandra 0. And this is written 40%. So we're at 4 million rows so far. So everything gets written here. So see this, all the data, the data directory. One of the things that that Easy Cast Lab will do for you is automatically set up your like do a bunch of nice setup stuff for you automatically. So like it drops this file in, and you can edit this before you do anything. So I set the NVMe drive, I set my read ahead. I set there's a bunch of kernel parameters. So it actually will do all these for you. So you don't have to do anything here. This is all done for you by default. So like you don't have to worry about running out of file handles, for example, or like, you know, max map count, or, you know, what's going on with like swap, or, you know, this whole thing. Like I'm really trying to make it so that it will just do the right thing for you, and to make it parameterized. So it's getting a little bit better over time. Okay, so this guy is going. So let's just take a look and see what's happening at the in our data directory. So random access. Oops. Okay, so this is funny. Because I'm using such a large heap, I actually am using mem tables that are fairly large. So this is just one mem table here. This is actually the first one that flushed at half a gig. Flushing large mem tables can be both good and bad. There's a trade-off. So if you flush large mem tables, then you have to deal with the fact that you do have them sitting in memory, which can result in more GC pressure. And so I'm using 30 gig heap. In fact, I'm going to go ahead and I'm going to change that. So I'm just going to show you how I change that real quick. So here, so if you, let's suppose you wanted to do, you know, you want something with mem table, right? You go user Cassandra current conf Cassandra YAML. And then we would go, oh, look at that, 2 gigs. Okay, so then easy use. So I'll just do this. Update config UC. So this will apply the new changes. So what we're going to do here, because this seems to be writing without much of a problem. Yeah, we're at we're at pretty low system usage here, like across the board, 9% CPU. So what I've done here is I've just let's see. This is like chugging along too. Okay, good job. Yeah, this is like no problem. Awesome. I can't wait for this populate phase to get done. Yeah, we're at 6 million writes. So basically what I'm gonna end up doing is because these writes are happening so quickly, what I'll probably end up doing is I may stop this and like start it again and just have it go faster. But look at this. I still haven't seen still don't see much of anything. So this was okay. So this is actually gonna force a lot smaller mem table flushes. I guess I could put in like a really tiny setting for this. I don't know. Let's just, before I do this, let's just make sure that it's up. I need to finish my rolling restart command. Okay. I'll just run this in Cassandra 2 as well. So see this is down now. This is Cassandra 2. As soon as this comes back up, I'll, there it goes. Oops. Yeah, I need to make a restart and wait script. I can, and then I can do rolling restart, which is nice. All right. Okay. Do we have anything in here that's useful for us? Nice. Cool. So done 66, 60, 50, 49. Okay, cool. So there's actually a decent number of queries being pushed through there. We're at 8 million now. So this should be done in just a sec. Okay, there we are. So because I made this smaller, and you know, it can definitely be good to increase the mem table space. Generally speaking, if you're finding that you're getting really long GC pauses, they can sometimes be correlated with larger mem tables and larger mem table flushes. If you're curious about how to figure out what's going on there, I'll just take a sec because this is still running. So this is actually pretty fun. So if we use ASProp, so I have a tool on here, ASProp. I talked about this quite a bit. I've written a couple blog posts on the topic. I'll just go here. So if you do this one's good. I dropped this. Yeah, I haven't used this yet. Async profiler is awesome. So we are going to be making heavy use of this in the training. I really, really love this tool. But for now, let's just go with heap. And this is kind of just like a shortcut that I have. Oops. Of course. Oh, unsupported untype. Okay, E, it's not heap, it's alloc. And if you can't see this, which is definitely possible, go to a bigger screen here. Okay, so this thing says profiling for 60 seconds. I know I'm on Cassandra 1. Nice. So let's jump off here, and I'll hop back on my main thing, and I'll just say SFTP Cassandra 0. One of the things that I've mentioned before is that all this tooling basically sets up a bunch of aliases and host information for you. Oh, here we go. Great, it's running. So here's the fun thing, max WLAT. This is actually going to find, so I told it to use 20,000 writes a second, but do a max WLAT of 10. So what this is going to do is it's going to hopefully dial in. Okay, let's just get rid of my populate phase in here. So I forgot to include how long I wanted this thing to run. So we're going to run up the same parameters, except I'm just going to do -D, and I'm just going to put 2H here. So this is going to run for 2 hours. I don't know if it's actually going to run that long. I didn't include drop here. If I'd included drop, it would have dropped the original data, but this is just going to go ahead and restart essentially the same workload. And what's cool is now it's starting at, because I told it to go to 20K, it's starting at a much lower throughput rate and stepping up until it gets to 20K. And then it uses the max WLAT to try to dial in the performance for the specified write latency. Because right now my write latency is like 2. And it's only 3,500, 4,000 requests a second. So this number is just going to go up, right? And the stepping only happens if it's within like 90%, I think, of the throughput that you're asking it to do. So it won't just like get carried away. If it can't achieve that throughput, it will basically just stop. Let's do another one of these because this is not helpful. So right now we're writing to Cassandra. We've got P99 of 2.3 milliseconds at about 10,000 writes a second to our 3-node cluster. Not crazy. That's perfectly reasonable. When we look at HTOP here, we can see that how are we doing? Oh no, I lost my cool thing. Oh, must be because I exited. Oh, that's a shame. Okay, don't do that anymore. So if we go to, let's see, meters, display options. So I think I want tree view and show custom thread names. I think that's what I want. There we go. I can do a search for Java. I come down here, I can actually see like what is going on. What is taking up CPU? Okay, so here it is. Everything that's under messaging event. Native transport, request response, mutation stage. Yeah. All right. All stuff that we're okay with seeing. We still see that our latency over here is really good. So one thing that's really interesting, and this question kind of comes up a lot of people measure performance incorrectly. People measure it only from inside the database, but that's not okay, because if you only measure from inside the database, then you're missing all of that time from the point that the client sent its request. It gets queued on the driver side, and then it travels across the network and then travels back across the network, and dealing with any networking issues that are happening along the way. So it's really, really important to always set that, because you will have a discrepancy. So here, our write latency is 179 micros, but over here, our latency is 2 milliseconds. So there's 2 milliseconds basically being added in somewhere from up to the point where the timing starts and timing ends. So I think it's, to me, and this is actually a part of a broader thing called coordinated omission. So if we're not timing if we're not scheduling, and one of the reasons why I updated this to use a scheduler instead of the previous design where it was more of like cooperative multitasking. The reason why I did this is because of coordinated omission. So now we're actually getting numbers that if you say 1,000 requests a second, it's literally putting in 1,000 a second. I wasn't capable of doing that before. I was capable of rate limiting it to 1,000 a second, but it would never, you could never like oversaturate a server. In my original, which, I'm glad I put this up. You can see that I specified max WLAT, and my original rate was 20,000. But look at this, like I'm past this. I'm at 20,000 now, and I'm still only at 2 milliseconds, 2.28 milliseconds of write latency. So this is going to keep going up. This is pretty awesome. I actually I'm really happy with this because it will dial in like fairly reasonably to what is your ultimate goal. Here I see we're still looking good. So let's just take a look at this node. All right, so it's almost 11. So I'm going to take one of these nodes and I'm going to tell it to rebuild. And we're just going to take a look at what's going on. All right, so here we're only using 5 gigs. So when we rebuild, this should be running. This shouldn't take long. And when we look at this, okay, so we have these files. This is a large one. This one's a little smaller. So these are all a little bit smaller. So let's just take a look and see what our compaction history is looking like. So now, maybe we can do this one. We do this in a virtual table. Forget if we have virtual table for this guy. Hope we do. Oops. Thought we did. All right, wrong. Mount. There is a compaction history. I knew it. Oh, system compaction history. Wow. Have we even done a compaction? Yeah. Okay, so it's only done 2 of these. Okay. Let's just try something. Because this is only one node, and we know that we can mess with a node. Cassandra 1, I'm just curious. If I do node tool compact, what will this look like? Anyone have any guesses? Sarma, do you have a guess? Oh, look at that. Probably a GC pause here. Did it reach a tipping point? See, this is kind of the funny thing is once sometimes you can like go from everything is great to like what is happening. Oh yeah, okay. So we must have it might have actually had multiple coordinated GC pauses, or not coordinated, but simultaneous GC pauses. This is one of the reasons why I want to fix the allocation problem, because we shouldn't have to worry about this stuff. Anyway, But you can see, if you look again, easy cast, stress run, random partition access. We're running this for 2 hours, although I'm not going to be here for I'm going to have to shut this down in half an hour because I have something to do today. But we're basically up around close to 30,000 requests a second. So this is just going along, writing nicely. Let's just see what happens if we do compact. Let's go to the directory first. All right. So this has done a decent number of flushes at this point. So I'm guessing that these bigger ones were the result of compaction happening. Now, if you notice here, it says they're all 690 and 691. I doubt that's an accident. So is that just a multiple of 171 times 1? What's 171 times 4? Oops. Do I have a calculator? Do I even have a calculator? $684. Okay, so this is probably just a result of 4 of these things being compacted together. Okay, so this is running great, 34,000, still increasing. I have a feeling that this is going to get significantly higher than this. I'm willing to bet that we are seeing. Let's see. So we're about 60% CPU usage. So let's just take a look here. 2 things before I start making changes, because I love, obviously I love making changes. One of the things about this environment is that it's really easy to just like not care and just start doing wild stuff, and then you're like, oh yeah, I forgot. So let's get an allocation graph. I'm going to get an allocation graph, CPU graph, and then I'm going to get an allocation graph and a CPU graph while I'm running compaction. So I'm going to get, what I'm going to do is I'm going to, let's see. So this is running, let's see. Do I want to get an allocation graph and a CPU graph? Do I want to get one or the other? I don't actually know if I can get them both at the same time because I've never tried. I don't know. I'm going to get an allocation graph because that's the thing that I really care about in 5.0. So if I can get an allocation graph and at the same time measure every IO operation. Let's do that. Let's do that. That'll be nice. So this is chugging along. Let's do this. Oh, I'm on the wrong box. Okay. So I can just do this. Keep. Open heap. Wrong window. There we are. So this is a heap histogram. This is the allocations that are happening while Cassandra is running under normal operations. And I don't think there's a compaction going on in here. Oh, there is. Cool. So it's actually not using. It's not. It wasn't that crazy. There was definitely a lot going on in other spots though. So when we look here, this is kind of where this is where we start to move into the um, the realm of like identifying how we can reduce GC overhead. So all these places right here, see like this, Java Lang object, B tree builder, byte. This is byte array, B tree row, like all these little things. If all of these can be eliminated, then you can essentially have, like, I mean, all of them, 100% of them. If you can eliminate all of them, then you basically have garbage-free compaction. It's great. But it's tricky because you have to be super careful about what you're writing. You can't have like temporary, like you can't read something out into a new byte array. You have to read it into an existing one, which means it had to have been created somewhere else and passed through. So a lot of the plumbing that exists in this code base, like a lot of the plumbing that is needed to do something like this doesn't exist in the code base. So it's going to end up being a huge refactoring. But you know, that's life, and it's not going to be what I do. So, all right. So we're just going to leave that there for now. This is our first heap profile. So we are still doing 29,000 writes a second, 32,000 reads a second. Our performance is looking awesome. So now what we're going to do is we're going to do this heap profile again. Okay. So I'm going to tee that up. There. So I think I'm on Cassandra 1. So I'll use this alias here. I'm also on Cassandra 1. I'm gonna move this out of the way. So this is I'm gonna track all of the time, and this is something that I haven't shown anyone before. I haven't done. So let's see. No, not that. No, not that. There is a nice tool called, I think it's CPU dist. Here, I'm just gonna share this. This isn't mine. What am I doing? I'm not hoarding this. Okay, here. This is a teachable moment. Off CPU analysis. So let's see what's going on here. What I'm going to try and do here, which I haven't done before, so it might not even work, is I'm going to run this off CPU analysis. I want to know exactly what's going on at the disk level. So first of all, let's just do it this way. We're going to run two things. One, we're going to trace every file operation. Nice. So see this PID minimum milliseconds, and then J. We're not going to use J. I love how they included J, but it's like comma separated. So we're going to do XFS slower -P for process syndicate, and then we're going to write this out. So let's actually just take a sec here. You know what? We're gonna jump on again. We're gonna jump on another box. Oops. Okay, more on Cassandra 1. So because what I'm doing is I'm just setting up a directory. In fact, it may already be here. Artifacts. Yeah. Okay. So I did set this up. So my artifacts. my artifacts here are things like this. So we're going to do this. Okay. Now I forgot something here. XFS slower by default registers slow file operations, but over 10 milliseconds. But I actually want to track every file operation. And I will explain why. This is actually, and this is this is all just part of this. Cassandra 15452. As I mentioned before, this is my my dream project here. My ultimate thing would be to fix this. This has been bothering me for years. I noticed what was going on when I was working at Netflix. I noticed that we couldn't lower our read ahead down too low, or streaming performance would be terrible. And so basically, I've been working out what the optimal read and write patterns are for EBS, and it turns out that we're just not doing them. Not just EBS, but like just drives in general. Like you don't want to do like tiny reads. You don't want to do a million tiny reads. You'd rather do 100,000 reads that are 10 times larger, generally speaking. So okay, so this is running here. We are about to get our profile, and I'm going to get this off CPU time as well. So let's see. And let's see if off CPU time actually does what it says it does. So I think, we can't see this. This is what I'm going for. So it looks like K is kernel. And so I'm going to get my kernel stacks. And P is going to give, that's the process. So basically what I'm going to do is, let's see, but there's one more thing in here that's important. There is a way, F, folded format. There we go. So let's just see what this does here. Okay. And okay, I should probably have done it a little bit smarter than that. So like, this says, so we want the PID. It'd be really cool if we had the thread ID, but I don't see that happening right now. Let's see. User stacks, kernel. You know what? I don't even think I want just the kernel. I think I want it all. Although I'm not sure what it's going to do on the. I'm not sure if it's actually going to get the Java symbols correctly. I don't think it will. So let's just say I do it with. Whoops. I want to fold them, and I'm just going to do it for like 1 second. We'll just see what it says. Look at that. Okay, so this is interesting. I'm going to save this. This is interesting. Let's save it for 60 seconds. And then we'll see how it goes. I don't know. All right. So I've got the XFS slower. I am I've got this guy up top that's going to do my heap histogram. I've got this one about to run. XFS slower is already running. Man, like losing track. Here we go. Interesting. So this occasionally has like spiked up. So these are probably GC pauses. So here we're like reliably getting around 25,000 requests a second. It's interesting too because you'll see like really wild numbers come out of Cassandra stress, like 800,000 requests a second, but I literally don't see that. Like here, this has done 38 million requests. So this is registered 15 million requests on native transport. Request response, mutation stage. So yeah, I'm never really sure what. Look at that, 38 million writes. So that makes sense given what we have here and when we restarted things. I'll never understand how Cassandra stress reports like crazy numbers. Anyway, that's not really the point of what I'm doing here. So okay, start the heap. Start off CPU and compact. Seems reasonable. Let's just go. As soon as this is done, I am going to hop on one of the other nodes. Well, I'm going to grab this data because I need this. And then I'm going to hop on one of the other nodes and just do a rebuild and just see what it does. Okay, so that's done. That's not. There we go. Cool. Okay. It's my dog. Most ferocious dog you'll ever hear. Oh. Oops. There we go. Oh no, did I overwrite it? I did. Lost my original one. This is why I need to add my nice flame graph tooling, my convenience tooling. No idea when I'm going to do that. Hey, look at that. Performance hurting. That's probably, again, GC. I really recommend, I'm going to make a recommendation here. GC Easy. If you're curious about like what's going on with GC, this is nice. You just upload your GC logs and they just do a really, really good job of giving you a summary. I have no affiliation with them at all. I just really like their tooling. So it might actually be interesting to like look at what's going on here. That's gonna stop. Okay, so now that, oh, there we go. The compaction is done. Great. Cassandra, data, whoops. Okay, so normally when you run node tool compact with size tiered compaction strategy, you end up with one really huge SS table. But that's actually not what I'm seeing here, unless I'm missing something. Let's see. Oops. Let me order by size. Cap S. Oops. H. Cool. Okay. So this is awesome. So size tiered tables will, it appears that they will, when you're running node tool compact, do it a lot saner. I think that this is actually because it gets broken up into like buckets. So I think that like the SS tables are actually partitioned. And then I think that I think they also break it like token boundaries. So this is really, really good to know. So if you're using, if you're using size tiered compaction right now, and there are use cases for it, and this is one of them, the random access, you might actually really benefit from UCS. Like this seems like it's a pretty solid replacement for size tier. Like I'm very, very close to saying that there is no valid use case for size tier compaction anymore. This just seems like it makes a lot more sense. And the reason why I like this so much is because it will work correctly with zero copy streaming, which I think I have enabled. Stream entire SS table is true, and I put a limit of 50 megs. So let's just go ahead and see what happens. Does it do it on a rebuild? I'm not even sure. Let's see. Okay, all these nodes are doing what? These are all not doing much. So let's just close these. Okay, we're gonna go ahead here. We're gonna look at Cassandra 0. Okay. I assume that we're going to see some information in the logs. So we're just going to keep the logs open. Okay. And we're also gonna, so while rebuild is running, we're just also, so this should tell us if it's streaming it out, presumably. So I'm on Cassandra 1. I'm going to rebuild on 1. It's going to stream in from 0. So we are going to want, let's see. There's like a TCP top. Why do I never remember those? All right. Fun time. So I'm going to hit this. I'm going to hit this rebuild, and I'm going to have just a couple minutes to observe it, and then I'm going to wrap things up. Okay. Okay, so this is actually sending a decent amount of traffic. Um, network. There we go. Look at that. Cool. Kind of makes me wonder, what if I were to do it without any limit? Okay, so if we are, we're able to transmit like a pretty quickly now. Should probably do a one-to-one comparison. Unfortunately, I'm not seeing. We're not doing a very good job of saying like when we're using zero copy and when we're not. Thought that there would have been more information about that. Ah, look at that. Stream Cassandra entire SS table stream writer. So in case you are curious and you want to see where that is, you can go there. All right, and then look at that. Then all of a sudden we see our GC pauses. Okay, so this is okay, but we need to do a better job of telling the operator when they're getting a stream like that. I'm gonna have to look into that. All right. Well, that's it for today. Hopefully the mix up in the time in the beginning didn't mess us up too much, but whatever. It's okay if it did. Yeah, I'm not sure what I'm going to be. Oh, next week I am going to be moving my session. I'm going to go to Wednesday. A lot of people said that they have been unable to join due to the day. So I'm going to try out Wednesday. Let's see what happens. Alrighty. Well, I'll see you around.